So we have this problem. Suppose two cars are racing on a circular track with a diameter of 1 mile. We've got two cars, car A and car B, are positioned 89 degrees from each other along this track. So the question is asking how far will car B have to travel before getting to car A's current location? I would pause the video right now if you want to try to draw a picture of this yourself, but with problems like this, it's definitely helpful to draw a picture. So we have our circular track. We're given the diameter of 1, which would be the distance all the way across the circle in the middle. And car A and B are 89 degrees away from each other. So if we want to know how far B would have to travel, we're finding this that I'm outlining right now, which would be an arc. S is the letter we use to represent arc length. And this is the formula. S equals R times theta, where S is arc length, R is the radius, and theta is the angle. We weren't given radius, but if we know the diameter is 1, half of the diameter is the radius. So half of 1 would be 1/2 or 0.5. Either one is fine. The number one rule for your arc length formula is that the angle has to be in radians. So right now we're given 89 degrees, but we can't just plug in 89. We would have to convert to radians. I'm just going to leave it as 89 pi over 180 until the end when I start multiplying. But for now, my angle is 89 pi over 180. So all that's left to do is multiply your radius, which was 1/2 of a mile, and your angle, which we converted to radians. And in your calculator, you should get something like 0.7766 something after that. So if you round to the nearest hundredth, like the question asks, that would be about 0.78. So remember, we're finding arc length, we're finding the distance from A to B, so this is a distance. And the problem was in miles, so 0.78 miles.